everyone, it's Alyssa and welcome to You Can Learn Math. Today is about probability. And this one we're going to talk about probability of just the odds of a specific thing, a single event happening, and also the probability of two things both happening. You may see this written in your book as the intersection of events. Fancy name, right? Has a fancy symbol too. Looks something like this. The probability of a intersection. It's like the intersection of A and B. Okay. So, yeah, that's the notation, but don't let that scare you. It's really not a complicated one, this one. Okay, first we're going to start with probability of a single event. Just one thing, just one. For example, let's say I have a die. Yeah, it's called a die, not a dice, two or dice, whatever. And I'm probably drawing this wrong. I know I am. I can't remember what size. I don't know. Okay. Assume that I knew how the dots go on a die. Oh, they're diagonal, aren't they? They are. They're diagonal. 1, 2, 3. I probably still drew it wrong. Anyway, this is a visual for a die. A die has 6 sides, and the numbers on it are 1, 2, 3, 4, 5, 6. First one would be, what are the odds, or what is the probability that if I roll this, and if the die is no one's cheating, what are the odds I will roll a 1? Well, there are 6 possible options. Sorry, I have the hiccups. I always get the hiccups when I'm talking for long periods of time recording these videos. I'm trying to keep it down. Okay, so there's 6 possible options. Of those, rolling the number 1 is one of those options. The odds are 1 in 6. Okay, back it up. What if I said, what are the odds that I would roll an even number? Well, there are 6 possible options. And let's see, 2, 4, and 6 are all even numbers. So 3 out of the 6 are even, 3 out of 6. And because this is presented like it's a fraction, I can simplify that to be 1 out of 2. Okay? What if I said, what are the odds that the number is less than 3 when I roll it? Again, there are 6 possible options. How many are less than 3? 2. 2 out of the 6 are less than 3. I can simplify that to 1 out of 3. And that's it. This same process, it's how many possible options are there. I'm so trying not to cough in your ear. I'm sorry. And how many possible options are there? And how many of those options are we looking for? All right, let's try another example. What if I had a coin? And that's George Washington right there. Woohoo. I know that doesn't look like a coin. I know. Okay, so I have a coin. This is supposed to be his slightly wavy hair. Oh, that's so bad. Does he have like a cravat or something? I don't know why I'm getting hung up on this. All right, so I have this coin, and we flip it in the air, and we say heads or tails. What are the odds that it will come up heads? There are 2 possible options, heads or tails. Heads is one of those. So 1 out of 2. Heads or tails. Get heads is 1 out of 2. Tails is also 1 out of 2. Here's the thing with probability. It doesn't change This never changes. If I flip a coin and it is a fair coin, no one's cheating, my odds of getting heads are always 1 out of 2. It does not matter if I have flipped that coin 5 times and I got heads and then heads and then heads and then heads and then heads. Sort of human instinct is to say, oh my goodness, heads has come up so much. Tails has to come up next. It has to. The odds don't change. It's always 1 out of 2. Always. Your odds are still even, it's a weird H, of getting heads or tails. So don't let that trick you. We're like, oh, after 5 heads in a row have come up, what are the odds of getting heads a 6th time? Still 1 out of 2. Nothing changes. Okay, now what if we're talking about 2 events happening together? And this is where you sometimes see this notation. If you're not using it, it's fine. Don't worry about it. But if you are, this is what we're talking about. We're talking about intersection. The intersection of events. And that's meaning, what are the odds of A and B both happening? So this will be something like, I'm flipping a coin. We're just going to do this time because that was really sad last time. I'm flipping a coin. I flip it 1 time, and then I flip it a 2nd time. What are the odds I get heads the 1st time, and then heads the 2nd time? Well, what are the odds I got heads the 1st time? There were 2 possible choices. Heads was 1. What are the odds on the 2nd flip that I would get heads? 2 possible choices. Heads is 1. To find out what are the odds of both of these things happening, this would be our A and our B. Or again, they write it as like that. We multiply. 1/2 times 1/2. Multiply the numbers on top. Multiply the numbers on the bottom. So 1 in 4, that's my odds of that happening. Same with rolling a die. If I have a die, and we're just going to write numbers on it because, you know, I'm not great at that. All right, so I have a die and I roll it. What are the odds that the first time I roll it, I get a 4, and the second time I roll it, I get a 5? Well, there are 6 possible outcomes for my first roll. 4 is one of those. To get a 5, there are 6 possible outcomes. 5 is one of those. Let me multiply. Multiply the numbers on top. Multiply the numbers on the bottom. 1 in 36. So far, so good, right? Okay. What if changed it a little and said, I want it to be on my first roll, I got an even number, and on the second roll, I got the number 6. Same principle applies. Okay, on my first roll, there are 6 possible options. How many of those are even? There's 2, there's 4, there's 6. 3 possible options. So 3 out of 6. To roll a 6 on the second one, there are 6 possible options. 1 of those is 6. I multiply. 3 times 1 is 3. 6 times 6 is 36. Now, I can simplify that because 3 goes into both of those. 3 goes into 3 1 time. 3 goes into 36 12 times. There is a sort of shortcut or an easier way to do this. You can simplify before you multiply because 3/6, I have such a hard time saying that, simplifies to 1/2. 1/2 times 1/6. 1 times 1 is 1. 2 times 6 is 12. Ding, ding, ding. We have an answer. 1 out of 12. So when you have these things where it's saying, what are the odds of this and that happening? Intersection. This and that. Of both these things happening. Those are the words you'll hear. This and that, both A and B, or intersection of A and B. this is what they want you to do. Find the odds of A, find the odds of B, multiply them. That's it. Okay, and one more I want to do, show you, this is a pretty common one, is where they're not independent things, they're dependent. And the one you'll most often hear is like socks in a drawer or balls in a basket. Excuse me. Okay, so socks in a drawer. They might say, all right, so I have a drawer, and in there I have, let's see, I have 2 pairs of red socks. They're folded together, that's why they're square. 3 pairs of red socks, 2 pairs of red socks, 3 pairs of blue socks, and 4 pairs of black socks. What are the odds I just reach in and I grab out socks because I don't care what I look like. I'm just going to wear whatever I pull out, even if it clashes horribly, I don't care. So I'm going to pull out a single pair of socks. What are the odds that I pull out a pair of red socks? We add up the total number of socks. 2 plus 3 plus 4 is 9. There are 2 pairs of socks that are red out of 9. My odds are 2 and 9. Okay, they're not going to leave it that simple though. This is what they're going to do next. They're going to say, okay, so let's say you pull out a pair of socks at random. You pull out your first pair of socks at random, and then without putting the pair of socks back, this is important, you pull out a second pair. Okay, what are the odds that the first pair is black and the second pair is blue? Right, so first one is still pretty straightforward. There's 9 pairs of socks in the drawer. 4 of them are black. 4 out of 9 are black. You go, okay, well, how many are blue? 3. 3 out of 9 are blue. No. Because that crucial piece of information saying, I took that pair of socks out and I did not put it back. There are no longer 9 pairs of socks in the drawer. There are only 8. Okay. So here on top, 4 times 3 is 12. On the bottom, 9 times 8 is 72. And I can simplify that to be 1 over 6. A little side note, if you are really good at simplifying fractions, and this is a whole thing for another video, so if you don't know how to do this, don't worry about it. It's not a big deal. Just watch another video on fractions and how we can simplify when you multiply. But if you already know how to do this, just a little reminder, you can simplify this before you multiply, saying we've got a 4 on top and it goes into 8 on the bottom. So 4 goes into 4 one time, 4 goes into 8 2 times, 3 and 9, 3 goes into 3 one time, 3 goes into 9 3 times. 1 times 1 is 1, 3 times 2 is 6. Again, if this is something that you're not familiar with, don't worry about it. You can still just multiply it and then simplify after. Perfectly fine. As you can see, you still get the same answer. No big deal. Okay, another very similar one, this is going to be the last one for these, is they'll say like colors, that you've got a basket and you have multicolored balls in there. Like say here we have 3 red and 5 blue. What are the odds? Let's say I pull out 3 balls and I do not replace the balls. I just pull a ball out, keep it, pull a ball out, keep it, pull a ball out, keep it. What are the odds that the first one is red, the second is blue, and then the third one is red again? What are the odds of this happening? Okay, so we count how many balls there are total. There are 8 balls. How many of them are red? 3. 3 out of 8. Now I've taken a red one out, so it's no longer there. Now, second round. What are the odds of pulling a blue one? How many balls are there total? 7. How many of them are blue? 5. Okay, so now I've taken a blue one out. It's out of the mix. Now, what's left? How many balls are there total? 6. How many of them are red? 2. I multiply these together. 3 times 5 times 2 is 30. 8 times 7 is 56. 56 times 6. Ooh, should have done this before. 336? Let me check that. Okay, let me do it the other way to double check it. 6 times 7 is 42. 42 times 8. 16 carry 1, 336. Hey! I feel weirdly proud whenever I do mental math like that and I get it right. Anyway, 3 times 5 times 2, 8 times 7 times 6. And we can simplify this. Let's see how we simplify this. If I divide both by 3, I get that down to 10 and 1, 1, 2. That can go further to 5 over 56. And that's as far as that goes. Okay, so 5 out of 56. Our little shorthand, again, for those who are familiar with this. Okay, I would say 2 over, this should be times. 2 over 6 is 1 over 3. Then 3 and 3 cancel out there. And I am left with 1 times 5 times 1 on the top. 8 times 7 times 1 on the bottom. Same answer. So again, that's a little quicker, but it doesn't matter if you're not familiar with it because as you can see, you can still get to the same answer. Okay, so that is how you do probabilities, and this is just probabilities where it's the intersect of this and that, or both things happening. Those are the words you're listening for. All right, I'm also going to do a video on some of the other things with probability. We're talking about probability of union and conditionals. That's for another video. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.